power supply. Alright, what we have here is a Rhodes 5-pin power supply and amplifier assembly. It's blowing fuses. Not only does it blow the normal standard 3 amp, but we even get it to blow a 5 amp. So we're going to try to trace where the problem lies. And it doesn't blow for a few seconds, you understand, but we're going to check resistance on the meter here to see what kind of a reading we get. There we go. Nine or 10 megohms. And there's some voltage on the capacitor. What we're going to do is try another approach. We're going to replace the 3 amp fuse that's in it. And we're going to put in a 3 amp fast rather than 3 amp slow blow. And what we're going to do is we're going to take the power amplifiers and remove the connectors such that nothing is connected, of course. And then what we're going to do, except for the power supply down below. Now, what we're going to do is first we're going to check we're going to remove this from the 15-volt power supply. We're going to check the diodes and rectifiers, and we're going to go to the diode scale, and I'll put the meter over here where we can see it. And what we're going to do is check and see if there's a problem with the bridge rectifier. That's often the case. That's a capacitor charging. Okay. No shorts so far. Alrighty, so what we're going to do, we have everything disconnected. That's the bridge rectifier down there. You just go around all 4 positions with the diode scale. We're going to make sure that these aren't shorted. That one is. So is that one. We have 2 shorted rectifiers. And they are in the 15-volt power supply. What we're going to do is we had already changed the capacitors in this because the ones that were in there were from 1976 and this is 2009 and they weren't doing too well anymore. So what we're going to do is remove the board. And verify that these diodes are bad again to make sure there's no question or problem. That one's good. That one's good. That one's shorted. And that one is shorted. So now what we're going to do is we're going to take, this is a 4-diode bridge, and unfortunately this particular diode isn't made anymore. It was made by GE. We're going to replace it with another diode that we have on hand, but we're going to change all 4 of them, and the reason is the forward characteristics of these diodes are different from the ones we have are different from the GE ones. So for safety reasons, we're going to change all 4. Alrighty, we're putting the diodes in, and in case you need any of these, we do have them. Just call us up and tell us what you need. And we're inserting this into the board. We didn't show removing them because that was much more fun. The problem with some of the boards that Rhodes put together is they used a tool which basically takes the wire leads and flattens them. And this was fine so they don't come out, but it is not so fine if you're trying to remove it, and therefore there's a problem. Anyway, that's what they look like, and we're going to solder the last one in. There we go. That's enough. And we'll get this one in. Okay. And we're just going to touch up a couple of pins here. There we go. Now the reason that we had previously removed all the connectors on this is to find the offending board. Basically, if you find the board that's screwed up and it's got a short on it, it'll blow the fuse. So if you take all the boards and unhook the connectors, you will find you shouldn't, unless this bridge rectifier or one of these capacitors is bad or the transformer is bad, you won't blow the fuse. And we'll prove that to you. We'll take a 3 amp fuse. This is a 3 amp fast. And normally what goes in here is a 3 amp slow. But we're going to take this in here, put the fuse in, and we're going to power it up to prove that it doesn't blow the fuse. There we go. It doesn't. The light's still on. Okay, I'm then going to connect the board we just worked on and try it again. And it doesn't blow the fuse now. So what we're going to do is we're going to check voltages on this board. And we're going to go between ground, which is this position right here, and this pin, which should be plus 15, and that pin, which should be minus 15. Well, it looks like that's not a problem. So what we're going to do is we're going to take these connectors and we're going to put them back. Now the power is off. And the power is now on. And no fuse blown. The light is still lit. So that appears that the shorted rectifier is our culprit. And now what we're going to do is we're going to check for the operation of this particular unit. I'm going to go between ground, which is the outside here, and this speaker lead. I hear a little hum. That sounds good to my ears. And we're going to sit there and connect an audio generator between ground and an input. We'll use that input better. And we're going to verify that we have output and that there is minimal distortion. That's full scale. It's about 50 volts peak to peak, so you're going to find that's the full output of the amplifier. We're then going to transfer to the other channel.